Hey everybody, I hope you're doing well. This is a small video on an introduction to optimization. Optimization is the way that we're going to be, or a method that we're going to use to optimize functions, finding maximums and minimums. We already have been doing that in terms of graphs, but these are real world problems. In other words, some world problems. So let me jump right into our first optimization problem. I have a whole bunch of stuff written already. Let me go through this slowly. We're going to start off by looking at some geometric shapes, and we're going to build our way up to more complicated optimization problems. So suppose I have a rectangle with a perimeter of 20 inches. Now there's lots of rectangles that have a perimeter of 20 inches. I could have a 1 by 9. I could have a 2 by 8, a 3 by 7. I could have a 7.5 by 2.5. Each one of those has a different area. What I want to find out is what's the largest area that can actually be made? Like the 9 by 1. 9 across, 1 down, then 9 across again, then 1 up. That is an area of 9. But an 8 by 2, that still has a perimeter of 20. That has an area of 16. So we can use our techniques of calculus, finding critical values, to determine what the actual maximum is. So the perimeter of a rectangle is 2 times the height times 2 times the width. And the area is x times y. But we have a constraint on this problem. We're saying that the perimeter, P, is always equal to 20. That's the given in this problem. So 20 is equal to 2x plus 2y, which I can write down as x is equal to 10 minus y. The idea here is to isolate one of the variables in the given. That's always going to be the case for the problems that we're going to be doing. Now, the idea here is to maximize the area, but the way I have area written right here, it's in 2 variables. So if I write this in 2 variables, I can write it in any order that I want. So I want to take this and substitute it in for x. I get y is y times 10 minus y, and now I have a function of 1 variable. It's just in terms of y. So I can use our calculus techniques. The goal is to maximize this particular function, but we have to notice something. And this isn't always true for every problem, but for this problem, the perimeter is always equal to 20. So that says this dimension can be no bigger than 10 because I have 2 pieces there, so it could be no bigger than 10. And since we're dealing with a dimension, it's never going to be negative. So we wind up getting a closed interval in here. Taking this equation, multiplying it out, taking the derivative, we get 10 minus 2y. Well, critical values is when we set the derivative equal to 0. We wind up getting y equals 5. And in fact, x is also equal to 5. Now, this is just a possible answer. Since we're on a closed interval, I still need to check the endpoints. So if I take 0 and plug it into the area function, I get 0. If I plug 5 into the area function, I get 25. When I plug in 10, that's the other endpoint, I get 0. 0, 25, and 0. What's the largest value? Well, it turns out to be 25. So 5 produces the largest area. Y equals 5, x equals 5 produces the largest area. I hope that small problem was helpful for you.